Students, in last video we learned expression for electric field at a point on axial line of an electric dipole. In this video, we are going to learn expression for electric field along the equatorial line. And again, in case of dipole, you already learned there are two charges, both are equal, but they are opposite in nature, plus and minus, separated by a very small distance to A. There are two important lines we learn. One is axial line and the one is equatorial line. In case of equatorial line, it is a line, perpendicular line passing through the center of a dipole. It is also called perpendicular bisector. And again, this OP line indicates the equatorial line in this diagram. Now, in case of this derivation, we consider two charge, plus Q and minus Q, separated by very small distance to A, that will constitute a dipole. We draw the perpendicular bisector or equatorial line. It is taken as OP. At a point P is at a distance R, you have to find out the electric field produced by the dipole. At a point P, there are two electric field are acting, is at a distance AP and BP. At a point A, we kept the charge plus Q. At a point B, we kept the charge minus Q. These two charge, plus Q and minus Q, produces electric field at a point P. The plus Q produces electric field at a point P, that will be taken as E plus Q. Minus Q produces electric field at a point P, it is taken as E minus Q. You already know about that. Positive charge produces diverging field. Negative charge produces converging field. Now, at a point P, there are two electric field are acting. One is E plus Q and the one is E minus Q. First, we think about magnitude of electric field due to plus Q and minus Q at a point P. To get the expression, the first thing is you have to calculate the AP and BP. AP is the distance where electric field produced at a point P due to plus Q charge. BP is the distance where electric field produced at a point P due to minus Q charge. Where AP and BP both are equal, by using Pythagoras theorem, here OP is equal to R, OA is equal to A. Now AP as well as BP both are equal to square root of R square plus A square. By using this, the magnitude of electric field due to plus Q and minus Q at a point P is E plus Q is equal to 1 divided by 4 pi epsilon naught. Charge is Q. Distance is equal to square root of R square plus A square whole power 2. Now E plus Q, we got this equation that E plus Q is equal to 1 divided by 4 pi epsilon naught Q divided by R square plus A square, that away from the charge because is a positive charged particle. Now again we can think about E negative charge is nothing but E minus Q. E minus Q is equal to 1 divided by 4 pi epsilon naught Q divided by R square plus A square towards the charge. It is equation number 2. The direction of E plus Q and E minus Q, the direction of E plus Q and E minus Q are shown in the diagram. The component of E plus Q and E minus Q perpendicular to dipole axis cancel away. That is nothing but, if you consider E plus Q, here it makes an angle theta from the horizontal. Because of this angle theta is resolved into two components, E plus Q cos theta, E plus Q sin theta. Similarly, E minus Q is in between horizontal and vertical with particular angle theta. Now is also resolved into two components, E minus Q cos theta, E minus Q sin theta. Here along the dipole, perpendicular to the dipole, E minus Q sin theta and E plus Q sin theta both are equal but they are opposite. These two will get cancelled. Now the component along the dipole axis, that is nothing but E plus Q cos theta, E minus Q cos theta, both are parallel to each other, gives the resultant electric field at a point P. That's why the resultant electric field at a point P is E vector is equal to E plus Q cos theta plus E minus Q cos theta into minus P vector. Is nothing but, again if you are going to consider E vector and P vector, both are acting opposite, that's why this negative sign will come. Now E vector is equal to, here E plus Q and E minus Q cos theta both are equal from equation 1 and 2. By using this, E vector is equal to 2 times E plus Q cos theta into minus P cap from equation 1 and 2. E vector is equal to minus 2 1 divided by 4 pi epsilon naught q divided by r square plus a square, that is from equation 1 and 2, because e plus q and e minus q both are equal, and again cos theta into p cap, that negative is taken already in this equation. From triangle AOP and BOP is nothing but this triangle, right angle triangle AOP and BOP. When you're going to consider these two right angle triangle with angle theta, you will get the value for cos theta, where cos theta is equal to OA divided by AP, that is nothing but OA is taken as A in a diagram, AP is nothing but square root of A square plus r square is equal to A divided by r square plus A square power half. That's why we can take cos theta is equal to A divided by r square plus A square power 1 by 2. From above equation 3 becomes E vector is equal to minus 2 1 divided by 4 pi epsilon naught q divided by r square plus A square. In equation 3 we can take as it is. In place of cos theta, we have to substitute A divided by r square plus A square power half into p cap. That simplification gives E vector is equal to minus 1 divided by 4 pi epsilon naught. Here this 2 is taken inside. 2 into A, we taken q divided by r square plus A square power 3 by 2 by adding r square plus A square and r square plus A square power 1 by 2. We got 3 by 2 into p cap, where P is nothing but Q into 2A. That's why in place of Q into 2A, you have to substitute P is nothing but electric dipole moment. We got electric field is equal to minus 1 divided by 4 pi epsilon naught P divided by r square plus A square power 3 by 2 into P cap. This electric field is parallel to the dipole axis, is nothing but this electric field is parallel to the dipole axis, where E and electric dipole moment P both are acting opposite with angle 180 degree. Here we got general equation E vector is equal to minus 1 divided by 4 pi epsilon naught P divided by r square plus A square power 3 by 2 into P cap. That is acting parallel to the dipole axis. For very short dipole, r square is very much greater than A square. We can neglect the A square. By neglecting A square, r power 2 and this 2 gets cancelled. We got general equation E vector is equal to minus 1 divided by 4 pi epsilon naught P divided by r cube into P cap. It is a final equation for electric field at a particular point along the equatorial line.